Welcome to part 1 of your lesson in scientific notation. In this lesson, you will learn how to convert numbers from standard form into scientific notation. The first thing we're going to do is talk about the structure of scientific notation. The first part of scientific notation is a coefficient. A coefficient must be a number between 1 and 10 in scientific notation. The number is then multiplied by a base 10. The final part of a notation is an exponent. The exponent becomes very important because it allows us to know how many times we need to move our decimal place and which direction. Let's see if we can make a rule on this using some examples. Our first example is a very large number, 2,600,000. We need to convert this number into scientific notation. We remember the first part of scientific notation is a coefficient between 1 and 10. Well, 2,600,000 is not a number between 1 and 10. So how do we achieve this in scientific notation? Well, we have to remember that right now, the decimal place in this number is right here, behind the final 0. If we move that decimal in a different spot to make a number between 1 and 10, we could have a coefficient. So what I'm going to do is move it from here to right here between the 2 and 6. So then I get a coefficient 2 and 6/10. You must remember the next step is multiplying this by a base 10. Now we must discover how we find our exponent. The way we find our exponent lies in the number of times we moved our decimal. We moved our decimal from here behind the final 0 to right here between the 2 and the 6. So let's see how many times that decimal place moved. Well, it moved 1, 2, 3, 4, 5, 6 times. So that makes our exponent 6. So now we can make a rule about our exponent. When we move our exponent left, the number of times we move the decimal is the number we put in our exponent. So let's try that in one more example. Let's convert 150,000 into scientific notation. So our first step, we're going to move our decimal from where it is, right here at the back behind the final 0, to over here between the 1 and the 5. 1 and 5/10 is in fact a number between 1 and 10, so we are correct. Our next step is to multiply that by a base 10. Now to find our exponent, we have to discover how many times we moved our decimal place. Well, we moved it from here 1, 2, 3, 4, 5 times left. That would make our exponent 5. So this is 150,000 written in scientific notation. 1 and 5/10 times 10 to the 5th power. This is what we can do when we're writing very large numbers in scientific notation. Let's see what our rule would be when we're converting very small numbers into scientific notation. In this example, 1,300 thousandths is a very small number. We have to convert that into scientific notation. We know our first step is to move the decimal so the coefficient is a number between 1 and 10. So we're going to move it here from where it is to between the 1 and the 3. Our next step is to multiply that by a base 10. When we were converting very large numbers into scientific notation, we learned that the exponent is discovered by counting the number of times we move the decimal. So let's do that now. Our decimal place moved 1, 2, 3, 4 times. So that would make our exponent 4. But you may have noticed this time we moved our decimal place right instead of left. Because of that, our exponent isn't 4, it's -4. So our rule is a movement right would make the exponent negative. In your next lesson, you will learn why these are equivalent. For right now, let's practice converting numbers that are very small into scientific notation. Here's your next example. Our next example, 38 thousandths, is a very small number. To convert into scientific notation, we need a coefficient between 1 and 10. If we move our decimal place, our coefficient would be 3 8/10. We then multiply that by a base 10. Well, how many times did we move our decimal? We moved it here 2 times. So our exponent would be 2. We have to also note that we moved our decimal right instead of left. So our exponent isn't 2, it is -2. Please pause the video and make sure you get these notes down. The structure of scientific notation, which is a coefficient between 1 and 10, multiplied by a base 10 with an exponent. Also make sure you get down our exponent rules on the bottom. The exponent is discovered by the number of times the decimal moves, and we also have to remember a movement left is a positive exponent and a movement right would be a negative exponent.